Hello students, today I am going to discuss with you one geographic term known as temperature inversion. You all know that during the daytime, due to the solar radiations, the surface of the earth gets heated up, and at night some absorbed radiations of the suns are radiated back to the atmosphere. This is the normal scenario what generally takes place, but how it works, we'll just see that. In the normal scenario, what happens as we go higher on the altitude, the temperature starts decreasing. And here the scenario is, this is the troposphere zone where the warm air which becomes less dense rises upwards, and upon it is the colder air. So the clouds are going to form due to the evaporation here, and then those are going to get condensed and precipitation will take place here in this zone. This is the normal condition where the colder air mixes with the warmer air. That is why troposphere is known as the zone of mixing or turbulence. Now this condition is actually unstable condition. This is not stable where the cold air is getting mixed with the warmer air. Now the condition which is not normal is the reversal, where the colder air which becomes denser, it settles down and the warmer air rises upwards to it. Now when will this happen? This will happen at the night time when the surface of the earth gets cooler and the cold air remains on above the surface of the air as it is dense, and above it is the warmer air, and this is known as temperature inversion. Actually, this state is very stable because there is no movement taking place in this type of scenario. Now, there are certain preconditions for temperature inversion. Let's have a look at it. There are certain preconditions which are required to form the temperature inversion. Here at this zone, we call it as inversion layer. Now, the conditions are, first one is long winter nights. Now during winter, the nights are much more colder, and as the temperature is very cold, the colder air gets saturated, gets settled on, near the surface of the earth. That is why the cold air remains here and the warmer air is upwards. The second precondition is cloudless sky. When the sky is clear, no clouds are there to trap the heat is directly radiated to the atmosphere or in space directly. So it leaves the surface to be cooler. The third one is dry air. Dry air means no water vapor content or no moisture present in the dry air. And when the air is dry, the air becomes cooler, and cooler air becomes denser, and that just gets settled above the surface of the earth. And the next one is slow movement of wind. When there is slow movement or absence of wind in the atmosphere, it doesn't distribute the heat horizontally, vertically, or in a circular motion, and the heat is straight up, is directed, radiated back to the atmosphere again without any barriers. So these are the preconditions for the temperature inversion. Now what are actually effects of this temperature inversion? We will get to see more foggy weather during the winter night. Now the effects of this kind of temperature inversion is the dust particles are going to hang around the surface of the earth. The second one is lower visibility. That is why during the winter season, due to the lower visibility, the transportation is not feasible. The third one is less rainfall. Less precipitation will take place because the warmer air is above the colder air. So no cloud formation won't be easy, and this will lead to lesser precipitation. And the last one is thunderstorm and tornadoes. As the convection process is not taking place properly, it will lead to the thunderstorms and the tornadoes. So here was temperature inversion, its effects, and what impact does it have on the environment. Now I am going to demonstrate it with a short experiment. Now let's start the demonstration. The yellow one is the warm water, that is the warm air, and this one is the colder air. This is the normal condition when the warm air is above the surface of the earth and colder, denser air is above the warm air. So we are just going to upside down it.
Yes.
Now you can see the mixing of the air. This is not the water for us now. This is when the warm air is mixing with the cold air. That is the mixing in the troposphere is going on. And this is how the condition becomes actually unstable, but which is favorable for the earth. And here we can see that warm water, that is the warm air, is on the top of the cold denser air, and there is no mixing. So this is known as the temperature inversion. Now students must notice one thing here. If you will see this layer, which is actually the mixing of the hot and the cold air, warm air and the cold air here, you will find there is a little bit mixing over here. Now this is what causes the fog and the mist actually, and this is generally noticed during the early mornings of the winters. So this is how we have experimented the temperature inversion. I hope the students must have got the clear idea with this experiment. Thank you so much.